Okay, let's break down this problem step by step, figuring out the Poynting vector for this electromagnetic wave. So we are given an electromagnetic wave in free space and we know its electric field. The electric field vector E is given by E naught times the sine of omega t minus k sub z times z, all in the j hat direction. We are also told that the magnetic field B is 0, specifically when t equals k sub z times z over omega. And the question is, what is the Poynting vector for this system? We have 4 options provided and we need to figure out which one is correct. Alright, let's get into the solution. We start with the given electric field, which is E vector equals E naught times the sine of omega t minus k sub z times z in the j hat direction. This equation tells us we have a plane wave, and the term minus k sub zz indicates that it's propagating in the positive z direction, which is the k hat direction. Okay, let's figure out the magnetic field direction. For a plane electromagnetic wave traveling in free space, the electric field, the magnetic field, and the direction of propagation are all mutually perpendicular. This propagation direction is given by the cross product of E and B. We know E is in the j hat direction and the wave is propagating in the k hat direction. Using the cross product relationship, E cross B equals the propagation direction, we can determine the direction of B. Applying the cross product rules shows that for j hat cross B's direction to be k hat B must be in the negative I hat direction. Now let's find the magnitude of the magnetic field. In free space, the magnitudes of the electric and magnetic fields are related by the speed of light, so E equals c times b. The speed of light c for this wave is given by omega over k sub z. So if E equals c times b, then b equals E divided by c. Substituting our electric field magnitude, the magnitude of B is E naught divided by c times the sine of omega t minus k sub z times z. Now combining the direction, we found negative I hat with this magnitude. The magnetic field vector is negative E naught over c times the sine of omega t minus k sub z times z, all in the I hat direction. Let's quickly check the condition given in the problem. B should be 0 when t equals k sub z times z over omega. If you plug that into the sine argument, omega times k sub z z over omega minus k sub z z over omega minus k sub z z, which is 0. Sub z z z minus k sub z z y sin sub c, all in the I hat direction. Okay, now that we have both E and B, we can calculate the Poynting vector S vector. The Poynting vector is defined as 1 over mu naught times the cross product of the electric field, and the magnetic field S vector equals 1 over mu naught times E vector cross B vector. Let's substitute the expressions we have for E vector and B vector. S vector is 1 over mu naught times E naught sine of omega t minus k sub zz in the j hat direction, crossed with negative E naught over c times the sine of omega t minus k sub zz in the I hat direction. Now let's work through this cross product. We can pull out all the scalar terms first. So S vector is 1 over mu naught times negative E naught squared over c times sine squared of omega t minus k sub zz. And then we have the cross product of the unit vectors, which is j hat cross I hat. Remember, j hat cross I hat gives us negative k hat. So substituting that, in S vector is 1 over mu naught times negative E naught squared over c times sine squared of omega t minus k sub z z times negative k hat. The two negative signs cancel out, leaving us with S vector equals E naught squared over mu naught c times sine squared of omega t minus k sub z z in the k hat direction. We are almost there. Our expression for S still has c's in it and the options don't. Let's substitute the speed of light c with its expression in terms of omega and k sub z, which is c equals omega over k sub z. So we substitute c equals omega over k sub z into our expression for S vector. S vector equals E naught squared over mu naught times omega over k sub z times sine squared of omega t minus k sub z z in the k hat direction. Now we simplify this. Dividing by a fraction is the same as multiplying by its reciprocal. So omega over k sub z in the denominator becomes k sub z over omega multiplied in the numerator. This gives us S vector equals k sub z times a naught squared of omega t minus k sub z into our k sub z. So the Poynting vector we calculated is S vector equals k sub z E naught squared over mu naught omega times sine squared of omega t minus k sub z z in the k hat direction. Now let's compare this result with the options given in the question. Looking at the options, our calculated vector exactly matches option number 4. Therefore, the final answer is option 4.